Well, this is a video to showcase what we did at the November workshop, Saturday workshop. And at that time, we were still working on making sense of what a fraction is, thinking about comparing fractions, focusing on what constitutes one whole unit when we deal with fractions. And all of that is going to lead up to eventually adding, subtracting, multiplying, and dividing fractions. But first, we really have to get control over what a fraction is and how to compare them and so on. And so during the workshop, we were really focusing on how students might be thinking about these fractions. And really, it's not, everything you see here today is not about these are different ways you should explain things to students. What we're going to see here today is just different ways students, or the teachers in our workshops, thought about some of the problems that we did during that Saturday workshop. For example, there was at one moment where I asked you to compare 3/5 and 2/3. That is, find out which of those two fractions is larger. And so, just to kind of get a little feel for this, imagine you're on a number line. And I'll just put, we know we're somewhere between 0 and 1, let's say. And we want to know, is 3/5 or 2/3, which one is to the left of the other in this number line between 0 and 1? And we might even think about where 1/2 is on this thing. So where are we relative to even 1/2? So what I saw on the Saturday workshop is we had one teacher explain it this way. They said, well, if you took a whole something, like say our whole fraction circles, and you cut them up into 5 equal parts, well, it would take 2.5 of those parts to put you exactly halfway, to put you at the halfway mark. Well, we have 3 of those parts. So 3 copies of 1/5 is more than 2.5 copies of 1/5. So that puts us to the right of 1/2. We're greater than 1/2 for sure. Likewise over here, if you took the whole fraction kit, circle, and cut it up into 3 equal parts, it would take 1.5 of those parts to put you at the halfway point. Well, we've got 2 of those parts, so we are, again, greater than 1/2. So in terms of the number line, we now know we're somewhere between 1/2 and 1. Well, what this teacher did on Saturday I thought was really nice. They said, okay, let's look at that. It would take 2.5 copies of 1/5 to put me exactly at 1/2. We have 3 copies of 1/5. That means we're 1/2 of a copy of 1/5 away from a half, greater than a half. Over here, it would take 1.5 copies of 1/3 to reach the halfway point, and we have 2 copies of 1/3. So again, we're 1/2 of a copy of 1/3 away from being at 1/2. Well, if you cut something up into 5 equal parts, compared to cutting something up into 3 equal parts, these parts would be smaller than these parts. In each case, we are 1/2 a copy away, 1/2 a copy of these bigger pieces compared to 1/2 a copy of these smaller pieces away from 1/2. So coming to the number line, this teacher reasoned that the 3/5 must be closer to 1/2 since 1/2 a copy of 1/5 away from 1/2. Compared to 2/3, so the 3/5 would be somewhere over here, the 2/3 would be somewhere over here, because the 2/3 is 1/2 a copy of a bigger 1/3 away from 1/2. So therefore, 2/3 was the larger fraction. So another group of teachers on the Saturday workshop approached this problem a different way. The way they reasoned about it was they probably had their fraction circles out and they pulled out 3/5 and they pulled out 2/3, and they're close enough where it was kind of hard to tell for sure. So imagine taking those 3 copies of 1/5. And if you took those 1/5 units and we cut each one of them up into 3 additional parts. So if you took a whole circle, cut it up into 5 pieces, but then cut each one of those pieces into 3 each, that would give you a total of 15. It would give us 15ths. And then likewise, we only have 3 copies of those 1/5, so those 3 copies would get cut up into 3 smaller chunks each, giving us 9. So 3/5 is equivalent to 9/15 1/15, but I want you to hear how we're making sense of that. It's not a procedure where you multiply the same number to the top and the bottom or something like that. What we're thinking about is this cutting and copying. Cut those 1/5 into three pieces each, giving us 15. Cutting those 3 copies of 1/5 into three pieces each, giving us 9/15. Likewise, over here, they cut the 2/3 up into additional pieces. The point was, what students find out naturally through working with the manipulatives is, it's easier to compare fractions when you're comparing all the same size pieces. And so, take those 1/3, we have 3 1/3, and cut them up into 5 pieces each. So if you have those thirds cut up into 5 additional pieces each, that would give you 15 total pieces. Now we only had 2 copies of those 1/3, but if I cut those 2 copies up into 5 pieces each, that would give us 10 total copies. So now what we have here is 9 copies of a 1/15 compared to 10 copies of a 1/15. Well, clearly 10 copies of that 1/15 piece is going to be greater than only 9 copies of that 1/15 piece. So therefore 2/3 is greater than 3/5. And there was even a third way to think through this problem. We had another group that thought about it this way. They said, imagine that 3/5. And what we're going to do this time is take those, there's really 5 copies of 1/5 in the whole, and we're going to cut them into 2 pieces each. That would give us tenths. Well, we only had 3 copies of 1/5, so we cut those 3 copies up into 2 pieces each, giving us 6/10. Over here with the 2/3, this group said, let's take the whole, cut it up into 3 equal pieces. I can imagine those 1/3. We're going to cut them up into 3 pieces each. Yes, 3 pieces each. That would give us a total of 9. But we only had 2 copies of those 1/3, and if you cut them up into 3 pieces each, that would give us 6/9. So what they did here is, instead of common denominators, this group was thinking about common numerators. Here we have 6 copies of a 1/10. Here we have 6 copies of a 1/9. Well, if you took a whole something and cut up into 9 pieces, those pieces would be bigger than if you took the same whole and cut it up into 10 pieces. These pieces would be smaller. So 6 copies of the bigger piece would be bigger than 6 copies of the smaller piece. So therefore, 2/3 again is the bigger fraction. So 3 different ways that students might reason through this, but look at the heart of all of it is about cutting and copying. It's this multiplicative view of fraction. So this focus, these activities are all about just giving students lots of opportunities to work with fractions, get more comfortable with fractions, challenge their thinking about what fractions really are. You can see connections to equivalent fractions. All of that work is going to be so useful when we get to addition, subtraction, multiplication, division. So another activity we did on the Saturday workshop was, given 7/12 and 7/11, find 3 fractions that are in between 7/11 and 7/12. Now with students, this is a really fun thing to do with students, because at first they just think there is nothing in between 7/11 and 7/12. But there are, of course, several ways we can think through this. First of all, let's think of it in terms of the number line. Where relative to 0 and 1 are these fractions on the number line? Like, let's start. Are they bigger or less than a half? Well, if you took a whole something, cut it up into 12 equal parts, and imagine those manipulatives, you could imagine what those 1/12 would look like. Well, 6/12 would give me a half. So 7/12 is going to put me just to the right of a half. Now over here, 7/11, if you took the whole, cut it up into 11 equal pieces. Since I'm cutting it up into fewer pieces, the pieces are going to be bigger than the 1/12 over here. And in each case, I have 7 copies. So 7 copies of these smaller pieces compared to an equal number, 7 copies of these bigger pieces. 7/11 is going to be a little bit bigger than 7/12. So 7/12 is somewhere on here, 7/11 is somewhere on here, and what we're looking for is 3 numbers that fall in between 7/11 and 7/12. So a strategy students might employ now is, at this stage we've been building up this idea of equivalent fractions, but not from a procedural point of view where they're just doing something to the tops and the bottoms, because that's what you're supposed to do, but instead they're thinking about cutting and copying. So for instance, imagine taking 7/12. So what if you took each one of those 12ths and cut them into 2 pieces each? That would give you a total of 24. Well, we have 7 copies of those 1/12, so we have to cut those into 2 pieces each as well to get an equivalent amount. So 14 24ths. Likewise over here, we could cut those 11ths into 2 pieces each, giving us 22. Those 7 copies of 1/11, those 7 copies would get cut into 2 pieces each, giving us 14 22nds. So now you have 14 copies of a 1/24th, and 14 copies of a 1/22nd. So in between there is 14 copies of a 1/23rd. Must be in between there. But that's only one number. I think we asked you for 3 numbers in between, and now I'm kind of stuck again, 22, 23, 24. So students might reason, let's cut them into even smaller pieces, but keep the amount, the same amount in the end. So take those 24s, 1/24ths, and cut them into, let's just do 2 pieces each. That would give you 48. I have 14 copies of those 1/24, so those 14 copies would have to get cut into 2 pieces each as well. Likewise over here, cut the 1/22nds into 2 pieces each. I'd have 44 of them now. I have 14 copies of 1/22nds, so cut those 14 copies into 2 pieces each, giving me 28 44ths. So now, 28 48ths, 28 44ths, what's in between? Couldn't I go 28 copies of 1/47th, 28 copies of 1/46th, 28 copies of 1/45th? There, I got 3 numbers in between. So you see here, it's not about, I'm going to teach my students this way because that's the easiest way. This would just be a way students might think through this if they are well grounded in thinking about fractions from a cutting and copying perspective. Another way students might approach it is something like this. Now, this, in my experience, happens more often with kids than it does with adults. But kids look at this, if they have this well-grounded cutting and copying point of view, they think of this as 7 copies of 1/12. So you take a whole, you cut it up into 12 pieces. Take 7 copies of those 1/12s. Take a whole something, cut it up into 11 pieces. So what would be in between? What would be in between cutting something up into 12 and cutting something up into 11 pieces? Well, cutting something up into 11 and a half pieces. Cutting something up into 11 and a fourth pieces, cutting something up into 11 and 3/4 pieces, whatever. So students will think about cutting things up into pieces, number of pieces in between 11 and 12. And there's lots of things you could do. Or maybe decimals. Maybe they'll do 7 11.1, 7 11.2, 7 11.3, if you will. Now this is good. This works. This is absolutely true. But maybe then you'd want to challenge your students to express these complex fractions in less complex ways. But still a valid approach and very ingenious. And then finally, approach that mostly adults take, more often than the students in my experience, is to ultimately get the common denominator. But even with that, let's kind of reason through that. Through some activities that you could do with students, they might find that it may not be the least common denominator, but at least a common denominator can be found by just finding the product of 12 and 11. And what you're really doing though is you're saying, take those 1/12ths and cut each one of them up into 12 equal pieces. 11 equal pieces. So 12 times 11, I believe, is 132. So if you took each of those 1/12ths and cut them into 11 pieces each, you'd have 11 copies of those 1/12ths, so we'd have 132s. And then we have to do the same thing to the numerator, cut them into 11 pieces each. 7 copies of them would give me 77 132nds. Over here, we'd take those 1/11ths and cut them up into 12 pieces each, thus giving us the 132. And if we had 7 copies of those 1/11ths and we cut them up into 12 pieces each, that would be 84 130 seconds. So what's in between 77 and 84 130 seconds? Well, 78 130 seconds, 79 130 seconds, 80 130 seconds, and you could keep going, but we only needed 3. But there's more. So again, the point is, we teach students the foundational way of thinking. It's about cutting and copying. Yes, fractions are also part to whole, fractions are also ratios, fractions are also, or could be expressed as decimals, and we want to be flexible in all of those, but we also want to have students see fractions from a cutting and copying perspective. And then we give them activities, we give them opportunities to practice those ways of thinking in contexts like this. And we let them see what happens. And we let them present, we let them share, we let them have this classroom conversation about what they're thinking. And all kinds of interesting things will emerge, and hopefully you'll be able to funnel all that into some powerful ways of thinking as we develop students who can ultimately make sense of problems and reason and all those things we love to do with AMP.